My name is Aziz. Welcome to the IBM Advanced Data Science Capstone project by Coursera. So my project is entitled Prediction of Singapore Airbnb Prices as of 27 Feb 2020. Now for the use case, so my aim for this project is to develop a regression model to predict affordable and accessible Airbnb properties in Singapore. So as everyone or most people will have known, Airbnb is famous for its online marketplace for renting temporary accommodations and short-term vacations. Singapore is also a highly attractive tourist destination in Southeast Asia and an ideal location for foreign businessmen and expats to expand their markets. Hence, this project aims to identify factors that influence the purchase or rental of Airbnb properties located island-wide. Now we explore the dataset. So the dataset is extracted from the official Airbnb website and updated as of 27 February 2020. The dataset is in Excel, separated values format, CSV, and the shape or dimension of the dataset consists of 16 variables with 8,047 observations. So for this project, our target variable will be the prices of the Airbnb properties in Singapore dollars. Okay, now we go over to the Singapore map. So Singapore is divided by 5 different regions. So the region that houses the city area, where the hustle and bustle of the towns and businesses is in the central region. So the city area is a place where the tourists visit frequently for its shopping destination and places of interest such as Garden by the Bay and Esplanade, as well as Singapore Flyer. And for the East region is where Changi Airport is located, and tourists will be welcomed by the newly built Jewel Changi Airport. Okay, going to the prices. So for this chart, is a box plot consists of the prices against the 5 different regions in Singapore. So observe that the central region consists of a high variance in terms of prices as compared to other regions. And other than that, we also notice some outliers in the other regions whereby the prices are above 1,000, in particular in the Northeast region and the East region. Okay, as we go deeper into the exploration, so from the bar chart, we can see that the entire home and apartment is the property that is most listed by the host, followed by private rooms. So as most hotels are located in the central region, so the other regions consist mainly of private or shared rooms. So from this dataset, we can see that the demand for private house or private homes and entire home rentals is greater as compared to other room types. A word cloud analysis was developed from the names of each Airbnb property. So the word room was removed and used as a stop word as it occurs too frequently. So on the word cloud, we can observe that the word MRT and private is heavily emphasized, as well as the word cozy, which indicates that the selling point for the Airbnb property is regards to the location of the Airbnb property to the nearest MRT or train station, as well as the comfort or the coziness of the property. Next, we'll be showing you the correlation map of the Airbnb dataset. So notice that most of the variables are weakly correlated to each other, or almost all the variables. So hence the use of simple linear regression will not be appropriate, as linear regression is ideal for variables which are highly correlated with each other. So hence we'll be using other forms of regression methods to develop the prediction model for this data. Data preprocessing and feature engineering was done firstly by removing columns that are not required for the training of models, such as ID, name of the Airbnb property, host ID and the host name. Next, the column reviews per month was also dropped as it had a strong correlation with the column number of reviews. Then a new feature was created to calculate the nearest distance of each B&B property to the MRT locations using dataset consists of the latitude and longitude of the MRT locations. Then the numerical variables are normalized using logarithmic scaling, and the categorical variables such as neighborhood and room types are encoded into numerical values using the label encoder in the scikit-learn library. Hence, the following learning algorithms were applied to train the model. So firstly, we use support vector regression, which is based on the support vector machine algorithm. This is actually a suitable model for variables which are weakly correlated to one another. Secondly, we use random forests. We use averaging to improve prediction accuracy and control overfitting. This is a form of Bayes ensemble model. Thirdly, we use the ridge regression, by which the loss function is the least linear squares formula, and the regularization is based on the L2 norm. Then we use the boosting methods, which is the XGBoost and the light GBM, to further improve the accuracy of the model. In addition to the use of these models, we also use a cross-validation of tenfolds in order to obtain the optimal error estimate on each model. On top of machine learning algorithms, we also apply a deep learning technique using artificial neural network based on the Keras library on the TensorFlow backend. So the model was built using two hidden layers of 128 neurons on the first layer and 64 neurons on the second layer. We actually use the rectified linear unit or the ReLU activation, including the output layer. And the maximum of 30 epochs was trained using the Adam optimizer to measure the mean square error and the mean absolute error of the ANN model. Then the model evaluation. So the following metrics were used to evaluate the performance of each learning algorithm. So firstly, the root mean square log error, the RMSLE. So we actually use this error instead of the RMSE, which is the root mean square error, since all the values are scaled logarithmically. Secondly, we use the mean absolute error, and thirdly, we use the R2 score. So the best model will be the one with the lowest RMSLE and MAE, as well as the highest R2 score. So from the models that are trained, so the learning algorithm with the best fit is the light gradient boosting model, or the LGBM, with an R2 score of 0.62. So secondly will be the extreme gradient boosting, or XGBoost, with an R2 score of 0.6. The models SVR and ridge regression showed undesirable R2 scores of 0.11 and 0.12 respectively. And lastly, the artificial neural network, or the ANN model, produced an R2 score of 0.46. In terms of the feature importance, using the light GBM regressor model, notice that the nearest distance and latitude and longitude are the top three most frequently used features in training the LGBM regressor. So this shows that location of the Airbnb property plays an important role in predicting the price of each property as compared to the other variables. So from the feature importance, we can see that the nearest distance, or the nearest Airbnb property to the MRT station, is the frequently used feature based on the LGBM regressor. So this concurs with the word cloud analysis done previously, by which the MRT was the most emphasized keyword used by the Airbnb host. Also, the latitude and longitude indicates that location-wise is also a selling factor for an Airbnb property to be purchased or rent by potential buyers. In terms of improving the model prediction accuracy, we use a stack regressor using the MLX10 library. So the three models that we use to combine form the stack regression model will be the light GBM model, extreme gradient boosting, and the ordinary least squares. So the meta regressor used for the stack model is also the XGBoost and the R2 score. After stacking these models together, improve with a score of 0.64. Here we have a summary of the R2 scores of each model. So we can see that the stack model perform slightly better than the light GBM and the XGBoost model. The SVR and the ridge regression are the ones that showed undesirable R2 scores, whereas the random forest and the ANN model perform slightly better with a score of above 0.4. So the further work that can be done from this project, we can actually use the name of the Airbnb properties using natural language processing to develop a topic model. In this topic model, we actually identify the correlation between the words used and the prices of the Airbnb properties. In addition, the calendar listings available can be used to perform hedonic regression of the Airbnb prices over time. And for that concludes my presentation of this project.